Okay, so let's do some examples. Hopefully this is okay. I'm going to keep Google Sheets open just for ease on the right side. So example 2, it says determine if you will use FV or PV in the following questions. Um, don't need that extra the. We do not need to answer the question. So those are the only two functions we've talked about, future value versus present value. So A says you know you will need $40,000 for your child's education in 18 years. So that's giving something away right there. If your account earns 4% compounded quarterly, how much will you need to deposit to reach your goal? This is the key thing. It's asking how much you will need to deposit. So that is why it's the present value function, because you need to figure out what you need presently to get to your future goal. Versus B says you deposit 4,000 in an account that earns 2.75% interest compounded continuously. How much will you have after 7 years? So I'm looking for what the future will have, so that's why it's FV. So hopefully that makes it a little bit more clear between the two, because you have to decide which function to use. All right, so the next couple of examples, it says write the formula used and the inputs in proper syntax. Answer each question with a complete sentence, including units. So this is really important. Anything you're turning into me, please make sure that you write out the formula and not just the number, because if the number's wrong, I don't know how to give you partial credit, and I want to make sure that you're actually doing the work and not just writing down the answer. So 3, it says how much would you need to deposit? Okay, right there, how much would you need to deposit? That gives it away that you need to do the PV function. In an account that pays 5.25% compounded monthly, so we talked about this in a previous video, compounded monthly means I'm going to use the number 12 because it happens 12 times a year, to have $20,000 in 20 years. So we have equals PV, and I don't know what the function's inputs are, so I'm going to rely on Google Sheets. So I'm going to put my equal sign, P, up, there's my function PV, so I'm going to select it. My rate is 0.0525 every 12 times a year, comma, number of periods, well, I do it 12 times in 1 year, and I'm doing it times 20 years. Payment amount, that's what I'm looking for, so it's a 0. And I'm looking for future value. I want to know what I need to get to $20,000. Make sure you don't put a comma in that 20,000. And remember, we don't use the end or beginning or type whatever spreadsheet you're using. I'm going to return it, and it looks like it gives us $7,014.80. So I'm going to select that cell again and write down what I have in the bottom. So 0.0525 divided by 12, 12 times 20, 0, 20,000. And it gave us $7,014.80. It also tells us to write in a complete sentence using units. So I will need to deposit $7,014.80. Okay, and the next question says calculate the total interest earned after 20 years. So remember, you only put in around 7,000 into this account. And after 20 years, you got to 20,000. So that's why we would take what we end with and take away what we put in. So I'm just going to use Excel. Equals 20,000. Be careful of those zeros. Minus, and this is the really nice thing. You can put in the number itself, but with this spreadsheet, you can just select the cell. And that's really nice because it puts in the entire value for you. So it's $20,000 take away what you deposited into your account. And it looks like, wow, over 20 years, you earned a total of 27,000. Oh, forgive me. Look at how I messed that up. Why did I mess that up? Because this is a negative, right? So I'm actually going to, I was like, that doesn't make sense. I'm actually going to end up adding it since it's a negative, which is the same thing as, okay, that makes way more sense. So I was like, huh? Okay, so it's going to be $12,985.20. So I earned a total of $12,985.20. Sorry, I said that wrong. $12,985.20 in interest. Okay. Example 4. You get an inheritance of $15,000 and you decide to put it into an account that pays 7.1 interest compounded continuously. So when I see that, that means I have to think of this EXP business. And then it asks, how much would it be worth in 25 years? So I'm looking to what I'll have in the future, so I know I have to use the FV function. So equals FV. Oh, but wait a minute. If I go back up to my notes, remember, continuously, we have to use this formula. So we actually don't use FV at all with continuously. And it's just because of how it's compounded. So this is going to be your principal, your original amount, times EXP, parenthesis, your rate, times how long we do this for, 25 years. So let's go over here. Equals 15,000 times, and then I'm going to do E, and you'll see these formulas show up. I'm going to choose EXP. And see how it prompts you exponent? Well, your exponent is your rate times your years. And what do we end up getting? Wowza. We are going to get $88,504.22. So after 25 years, I will have $88,504.22. Wow. It's pretty hard to find an interest rate at 7.1%, but now that's a big number, so I'm just going to double check that I put it in right, and I look at the formula below, and everything looks good. It was 15,000, my rate is right, and my years are right. Okay, great. Calculate the total interest earned after the 25 years. Okay, well remember, we ended up with $88,504.22, and we put in 15,000. So once again, I'm going to do it on my Google sheet. So equals this value, take away 15,000. And that 15,000 is right. And it looks like we get $73,504.22. So I will have earned $73,504.22 in interest. That is amazing. Just letting it sit there. All right. Example 5, and then we'll talk about a new term. You decide to save your tax refund of $1,000 in an account that pays 6.5% compounded quarterly. So quarterly, remember, is 4. It says, how much would you have in 15 years? Okay. Remember, it's going to be FV because I'm looking for my future value. And because it's not continuously, I can use the FV. The continuously is just special. So FV, I don't know what the formula needs, so I'm going to do equals FV is right there. Okay, my rate is 0.065 divided by the 4, because that's how many times you're doing it in a year. You do it 4 times a year for 15 years. Payment amount, that's what we're looking for. So, oh, no. So that is 0. And then we know our present value is $1,000. And then I'm going to push enter. And it looks like we get $2,630.47. So let's go ahead and write down our formula. Divide by 4. 4 times the 15. 0. We talked about that earlier because you only put in 1,000 once. I'm going to check all my work down here. It looks good. And remember, it gives out a negative because of accounting and just how it's programmed. So we could have put in a negative 1,000 to offset that if you don't like getting a negative. So I will have $2,630.47 in 15 years. What's the interest? Okay, well, we can probably just do this in our heads, right? If I end up with $2,630.47 and I put in 1,000, looks like I'll have $1,630.47 in interest. So I earn $1,630.47 in interest. Okay, see you next time.